Hi everyone. In this video, we are going to discuss about how to calculate the trigonometric ratios of angles like 90 degree minus theta, right? That's like a complementary angle. I have already created a video on the concept of unit circle and the concept of trigonometric function, and we are going to use the same concept here to derive the trigonometric ratios of such angles. Now, before we go into 90 degree minus theta type of angle, let's first quickly revise the concept of our trigonometric function in a unit circle. Say, suppose in this diagram I have a unit circle where the radius of the circle is 1 unit and the center is at O, and if we take a point P on the circumference whose coordinates are x, y, then we know from the concept of trigonometric function of a unit circle that the x coordinate would be equal to cosine of theta and y coordinate would be equal to sine of theta. Now what is theta? Theta is the angle that's created by the line segment OP with the positive x-axis. Please always remember, this is the angle with the positive x-axis, not with the negative x-axis. It's always with the positive x-axis. So this is the angle created by the line segment OP with the positive x-axis. Now we have to find a point Q on the circumference of this unit circle such that OQ will create an angle 90 degree minus theta with the positive x-axis. So now I'm going to plot the point Q on the circumference of this circle and I'm going to show you what that 90 degree minus theta angle is. I have plotted a point Q on the circumference of the unit circle so that OQ line segment creates an angle 90 degree minus theta with the positive x-axis, and I have denoted that with a red arc here. Now if that angle, I mean the angle QOA is 90 degree minus theta, then think about what would be the size of the angle QOB. Well, that will definitely be theta because the sum of those two angles will be the 90 degree angle which is on the first quadrant, meaning on one side of the y-axis and x-axis in one quadrant, the total angle there is 90 degree. Now if QOA is 90 degree minus theta, then definitely QOB will be equal to theta, right? You need to clearly understand that when QOA is equal to 90 degree minus theta, then QOB will definitely be theta degree, and that is how I drew the angle, because I didn't know how to draw 90 degree minus theta, so I simply first plotted theta, then we said okay, if theta is this much, then the rest of it will be 90 degree minus theta. So let's assume the QOA angle is 90 degree minus theta, and we have to find out the coordinates of the point Q which will actually represent the trigonometric function of cosine and sine. From the concept of unit circle and trigonometric functions, we know that the x coordinate always represents the cosine of the angle and the y coordinate always represents the sine of the angle. Now in this particular topic right here in this video, the angle is 90 degree minus theta, so you need to be very careful about that. Our angle here is 90 degree minus theta. We are not talking about theta, we are talking about 90 degree minus theta, that angle, right? So the x coordinate of Q will be equal to cosine of 90 degree minus theta and y coordinate of Q will be sine of 90 degree minus theta. So our task here is to find out the x coordinate and y coordinate of Q which will represent the cosine of 90 degree minus theta and sine of 90 degree minus theta, right? Now if you look at the two triangles that I have drawn here, the triangle OAP and the triangle OBQ, if you look at those two triangles, you will realize that they are actually congruent triangles. Now why I say that? Well, their hypotenuse length is equal because that's the radius of the circle, and then they have an equal angle which is the theta angle. That means they also have another angle which will be 90 degree minus theta. This little angle right here, these angles I'm drawing it with a green arc there, these angles will also be 90 degree minus theta. So now you see they have hypotenuse of same length and the two adjacent angles of the hypotenuse, they are also of the same size. That means both triangles are congruent triangles. So let me write that down. Now if the two triangles are congruent, then we can easily say that OA will be equal to OB. Those are the corresponding sides. And also we can say that AP will be equal to BQ because they are also corresponding sides of those two congruent triangles. So now let's try to find out the trigonometric ratios of 90 degree minus theta, right? So what would be the x coordinate of the point Q? Well, x coordinate of the point Q will be cosine of 90 degree minus theta. That is our main angle of the topic, right? And the cosine of that angle will represent the x coordinate of the point Q. So can we write it like this? So here I have written cosine of 90 degree minus theta, that is same as the x coordinate of the point Q, because OQ has created the angle 90 degree minus theta with the positive x axis. So whatever is the x coordinate of the point Q, that will be same as the cosine of that angle. And in our topic of discussion, the angle here is 90 degree minus theta. Please remember, we are talking about 90 degree minus theta. So the cosine of 90 degree minus theta will be equal to the x coordinate of Q. And now if you think about it, what is the x coordinate? Well, that is actually the length BQ. It's same as the length BQ. If you think about this rectangular coordinate system here, the x coordinate of Q will be equal to the length BQ. So can we write it here like this? So can we say this will be equal to the length BQ? And then from right here you can see that BQ is actually equal to AP. So can we write it as AP? And then up there, as you see, AP actually represents sine theta. You see right here, I am doing a green underline there. So AP actually represents sine theta. So from here, can we say, okay, if this is equal to AP, then that must be equal to sine of theta. So we have found the trigonometric cosine ratio of 90 degree minus theta, and that comes out to be sine of theta. So let me make a quick note here. So if we want to write down the x coordinate of Q in terms of x and y, right? So the x coordinate of Q will be cosine of 90 degree minus theta, which is again equal to sine of theta, and that is again equal to y. As you can see right here, I am doing a pink underline here. Sine of theta is actually equal to y. So the x coordinate of Q will be equal to y. And then let's try to find out what would be the y coordinate of Q. And the y coordinate of Q obviously will be sine of 90 degree minus theta. And if you look at our diagram, the y coordinate of Q will be actually equal to the length OB. And then again, as you see from the relationship of the two congruent triangles, OB is actually equal to OA. Let me do a green underline right here. So OB is equal to OA. So can we write it as OA then? And then OA is equal to what? Well, OA is actually equal to cosine of theta. You see up there, I did a green underline. So OA is actually equal to cosine of theta. So we have calculated the value of sine of 90 degree minus theta, and that comes out to be cosine of theta. So let me make a note here. And going back to the diagram, if we have to indicate the y coordinate of Q, and that y coordinate of Q is actually equal to sine of 90 degree minus theta, and here we see that sine of 90 degree minus theta is nothing but cosine of theta. And then again, if we scroll up a little bit, you will see that cosine of theta is actually x. So cosine of theta is actually x. I am doing a pink underline there at the top. Cosine of theta is actually x. So what would be the y coordinate of Q? Well, y coordinate of Q is actually sine of 90 degree minus theta, which is equal to cosine of theta, which is again equal to x. So I am simply writing y comma x. So now we have found out the coordinates of Q, that is actually y comma x, when x and y are the coordinates of the point P, when OP creates the angle theta with the positive x axis, right? But again, don't worry too much about the point P. We are just using theta as a reference, as a basis. We are trying to express the ratios of 90 degree minus theta in terms of the ratios of theta angle. That is our main base angle, right? Theta angle. So with that basis, we are trying to represent what would be the values of sine of 90 degree minus theta, cosine of 90 degree minus theta, and so on, right? So theta is our basis here, but again we are calculating the trigonometric ratios of 90 degree minus theta, and we are trying to express that in terms of the ratios of theta. And then let's try to calculate tangent and the other ratios of 90 degree minus theta. So now that we know the sine and cosine of 90 degree minus theta, then we can calculate all other trigonometric ratios using the trigonometric identities. We really don't need the unit circle anymore. From the unit circle, we have been able to determine the values of sine of 90 degree minus theta and cosine of 90 degree minus theta, and that is enough for our purpose, right? So now let's try to calculate those other ratios. So let's calculate tangent of 90 degree minus theta. We know tangent is actually the ratio of sine and cosine. So we can write it as sine of 90 degree minus theta divided by cosine of 90 degree minus theta. Now what is the value of sine of 90 degree minus theta? Well, that is actually cosine of theta. So I am writing here cosine of theta. And then what is the value of cosine of 90 degree minus theta? Well, cosine of 90 degree minus theta came out to be sine of theta. So here I am writing sine of theta in the denominator. And now if you think about it, so cosine theta by sine theta, that is actually cotangent of theta. So that is actually cot of theta, cotangent of theta. So we have been able to calculate the value of tangent of 90 degree minus theta in terms of a ratio of theta. Next, let's calculate the cosecant of 90 degree minus theta. And we know from the identity of trigonometric ratios that cosecant of 90 degree minus theta is a reciprocal of sine of 90 degree minus theta. Cosecant is actually a reciprocal of sine, so we can write it as sine of 90 degree minus theta. And then what is the value of sine of 90 degree minus theta in terms of theta? Well, that is actually cosine of theta. As you can see up there, sine of 90 degree minus theta is same as cosine of theta. So we can write it as 1 divided by cosine of theta. And now what is 1 divided by cosine of theta? Well, that is actually secant of theta. So that is sec theta or secant of theta, right? So we have been able to figure out the value of cosecant of 90 degree minus theta, and that is equal to secant of theta. So let me make a quick note here. Next we are going to calculate the secant of 90 degree minus theta. We know that secant is actually the reciprocal of cosine, so we can write it as 1 divided by cosine of 90 degree minus theta. And then what is the value of cosine of 90 degree minus theta? Well, that came out to be sine of theta. As you can see up there, cosine of 90 degree minus theta is actually sine of theta. So that's the value I'm going to use here. So this will be 1 divided by sine of theta. And what is 1 divided by sine of theta? That is actually cosecant of theta, because cosecant is the reciprocal of sine. So we have been able to calculate the value of secant of 90 degree minus theta, and that comes out to be cosecant of theta. So let me make a quick note. Finally, we are going to calculate the cotangent of 90 degree minus theta. We know that cotangent is the ratio of cosine divided by sine. So we can write it as cosine of 90 degree minus theta divided by sine of 90 degree minus theta. Now what is the value of cosine of 90 degree minus theta? Well, we have already seen that this is actually sine of theta. Cosine of 90 degree minus theta is actually sine of theta, and then sine of 90 degree minus theta is actually cosine of theta. And now what is sine divided by cosine? Sine divided by cosine, that is actually tangent. So this is now tangent of theta. So we have been able to find the value of cotangent of 90 degree minus theta, and that seems to be equal to tangent of theta. Let me make a quick note. Alright, so we have calculated all 6 trigonometric ratios of 90 degree minus theta angle using the concept of sine and cosine function of the unit circle. So as you can see, we actually wanted to represent the ratio of 90 degree minus theta in terms of the ratios of the theta angle. Why? Because we already know how to calculate the ratios of acute angles. Let's assume that theta is an acute angle. We have already created a video where we have explained how to calculate the trigonometric ratios of an acute angle theta, say for like 30 degree, 45 degree, 60 degree, 90 degree and 0 degree also. So because we can easily calculate, or because we already know the trigonometric ratio values of an acute angle theta, now whenever we have crazy looking angles like 90 degree minus theta or 90 degree plus theta or even 180 degree minus theta or 180 degree plus theta, those type of angles, right, we always want to simplify and somehow you want to try and represent that as a trigonometric ratio of theta angle, and that is exactly what we tried to achieve here, right? And as you can see that we have been able to express, or we have been able to derive the values of trigonometric ratios of this 90 degree minus theta angle in terms of the trigonometric ratios of theta angle. I hope everything made sense. Thank you for watching. See you in the next video.